Here's the demonstration for the area of a regular six-sided polygon, called regular hexagon. This is also a way to remember how to calculate the area without remembering the formula. Because this is a polygon with 6 sides, all internal angles must equal 720 degrees, and because there are as many sides as there are angles and this is a regular polygon, all angles are equal to 120 degrees, we can trace two diagonals that connect two vertices of the hexagon such that they create two 90 degrees angles each. This also creates four 30 degrees angles, dividing the area of the hexagon into a rectangle and two isosceles triangles. We can further divide this by tracing the diagonal connecting the remaining two vertices of the hexagon, which is perpendicular to the other two diagonals we have traced. Because it's perpendicular, it divides the two isosceles triangles into four congruent right triangles. Also because it is perpendicular to the diagonals, thus it is the height of the two triangles. It is also the median, splitting the two diagonals in half. We can use trigonometry to determine the correlation between the three diagonals we have traced and the sides of the hexagon. We know that the adjacent cathetus in a right triangle can be calculated using I times cosine of alpha, where I is the hypotenuse and alpha is the angle between the two. Because the hypotenuse is s and alpha is 30, this can be written as s times cosine of 30 degrees. We'll label this part of the diagonal L. Remember this equivalency. Now we can use trigonometry again to determine this opposite cathetus, which is calculated with I times sine of 30 degrees. Sine of 30 degrees is a particular value of the sine function which is exactly equal to 1/2. So we can write this as 0.5 times s. We'll label this part of the diagonal h. Remember this equivalency. Now we can calculate each area separately to get the entire area of the hexagon. The big rectangle is 2L times s. Because area equals base times height, then the triangles would be 2 times h all over 2, but because there's two of them, the sum of their areas is just 2L times h. This means that the area of the hexagon is 2L times s plus 2L times h. Factoring out 2L, it becomes 2L times s plus h. But remember how h was in reality just 0.5 times s. This means this can be rewritten as 2 times L times 1.5 times s. Or 3 times L times s. L is actually equal to s times cosine of 30 degrees though, so this can be rewritten as 3 times s squared times cosine of 30 degrees. Cosine of 30 degrees is also a particular value of the cosine function which is exactly equal to the square root of 3 over 2. So the equation can be, at last, be rewritten as 3 times the square root of 3 times s squared all over 2, which is, in fact, the formula for the area of the hexagon.